Hello there, it's Jay here from Jay's Vintage Junk, and today we're not looking at the Auric Atmos at the moment because I'm waiting for some spare parts to arrive on it. I've just ordered some spare parts to get the keyboard working. So while we're waiting for them, I thought we would have a look at this here. I picked this up earlier in the week off eBay. It was local to me. It was about 20 minutes off my route home from work, just up in one of the villages near me. It's a Macintosh LC, and I got the computer, keyboard, mouse and monitor, and I paid a tenner for the lot. It was a collect only auction, and obviously I was the only person interested in this stuff in a reasonable distance because there was no other bidders on it. It was sold as non-working. The reason I bought this actually was not for this computer. I also have, and I've had it lying around for years, I've had this. This is a Macintosh 2SI. Now this is, I think this is slightly older than the LC. The LC was Apple's budget colour Macintosh. It was really pared down. It's actually quite limited. This was a bit more of the Apple's power line type thing, even though it's a slightly older than this one. It's got a faster processor on it, it can take more memory, things like that. It's got more expansion in it and all sorts of stuff like that. I've had this for years. I can't even remember where I picked it up from, but apparently it's property of City College Manchester, which yeah, it's an old college computer. And all I had was this and the mouse. I didn't have a monitor for it, I didn't have a keyboard for it. A little bit later I did actually get a keyboard that would work on this because I got a Mac Classic, which I picked up again cheap from an auction, which is going to be on another video soon because that needs work on it. But I still didn't have a monitor for this, so I had no way of trying it. I had no way of, unless I started messing about trying to make a cable for it to rug it up to a different monitor. And it's literally, I think I got this in the late 90s. And it's sat in the cupboard under the stairs until a couple of days ago. This is going to be the subject of another video on all its own, because I did plug this in, hoping to get it to run on the keyboard, mouse and monitor that I got with this, and I put power up to it. I pressed the power on the back and there was a bang. The power supply went banging it quite loud actually. Obviously cap's just gone popping it. I did open the top of it and it has some serious battery leakage in this. I don't honestly believe I'm going to be able to get that working. The CMOS battery's been left in there, it's corroded. I've never actually seen quite such severe corrosion in a computer as actually is inside this one. It literally does look like it's spent, you know, a year underwater. That's all I can describe it as inside. Anyway, I'm going to do this on a completely separate video, so ignore that computer for now. I will take that out of shot. So what I thought we'd do, it seems I got all this as a complete package, and I need to test the keyboard, mouse and monitor anyway. I thought I'd see if we can get this old LC up and running, and at least then I've got a nice classic Mac actually up and running that I can play with. So right, let's get a start on this. All we're going to do on this video, I'll probably do a two-parter on this, is see if we can get this thing to fire up, because at the moment, let me just grab an IEC lead. I've got the good old IEC lead here. We'll shove this in the back. Now these LCs don't have soft power like most Macs, they actually have a proper power switch on the back, so we'll flick the power switch on and absolutely nothing. It's dead. If you've got good hearing and you stick your ear really close to the power supply, you can hear a high-speed ticking coming from it. So I'm pretty sure we have power supply issues. That's why it's not firing up. I've had a quick look online, and apparently these are very, very common for developing power supply problems. And there's just a few caps in the supply which usually cause them problems. So we'll get the supply out of this, we'll do a few checks on it, we'll get it open, and we'll have a look at changing them capacitors in there, and we'll see just if we can just get this thing to fire up, perhaps get it to make any noise, get the hard drive and the fan to spin up on it, and we'll leave it at that for today. If we can get this to work, I'll be quite pleased up to that point. And then we'll do another video and I'll connect it up to the monitor and keyboard and everything, and we'll actually see. I don't even know what's on this thing. Like I said, I haven't got a clue. I'm not actually a huge Mac person. I've got a few of them kicking about. Relatively recent, up to, I think I've got a Mac Plus or an original Mac or something like that kicking about somewhere upstairs. Again, I am going to do some more Mac videos because I thought they're a part of computing history I have neglected, really, so I thought I'd see what I can do. So let's get in this thing, and these are nice and easy to get in, I must admit. The screw is already missing from there, but two plastic clips. We pull the clips up and the top comes off. Even if this computer is not repairable and we can't do anything with it, it's not a complete and total loss to me. It's got a 40 meg SCSI hard drive in it. So's the two SI's also got a small SCSI hard drive in it. So if I can't do anything with either of these computers, or I can only get one working, I'm hoping that I can use one of these spare SCSI hard drives in my RM Nimbus 186. Because I've been really struggling to find a sub 160 megabyte SCSI hard drive to get that computer fully up and running. So there may be a chance that one of these small hard drives ends up in my RM Nimbus, and perhaps a bigger hard drive ends up in one of these two computers, but that's in the future. The first thing we want to do is see if we can actually get this up and running. So what we will do is we will take the power supply out, and we'll just unplug it here, like that. Now these are fairly easy to remove from what I've seen. They're one of these, what they describe them as, that you don't need any tools to work on it. It's toolless access and all this. And still you need a screwdriver. You have to force these clips back, one either side, and then you can get the PSU to lift up like that, and it'll just pop out. So we'll get this out of the way for now. Let's get that out of the way. And let's have a look at the power supply. Now first things first, I wonder if we've got any voltage out of it at all. So what we'll do, we've got the, I don't know if you can see this on the camera. Let's see if I can tilt you up, see if you can see the, yeah, you can just about. You can see my display up here, that's a little multi-tester. We'll switch that to voltage. We will make sure it's set onto DC, which it is. We'll set it to 100 volts because we're going to be monitoring the 12 volt line on this. We've got our probes. In fact, I'm swap that probe for a different one, because sometimes it's useful to have a alligator clip as one of your probes, like this. See if we can see any of this on shot. Sometimes it's useful to have an alligator clip like that as your probe. Other times you're much better with two proper probes like that. So we'll plug that into my tester. So we've got two proper probes like that, and we see this on shot. Oh, I've got the power supply. Let me just see if I can perhaps pull the camera down a touch so you can see what's happening. Righty-ho. So first thing we're going to do before we even go inside this thing is we're just going to see if we've got any voltages coming out of the connector there. Now we can assume that the blacks are ground, so I think we've got something like plus 12 volts, plus 5 volts, and either minus 5 or 12 volts on the other rail there. Let's get some power up it. We'll just run it like this on the bench. Let's see if we've got any voltage coming out of this at all. We'll connect to one of them, which I think is one of the grounds. A good connection there, and we'll go on the blue one, which should be one of the voltage lines. We'll switch the power supply on, and there's nothing there at all. Let's make sure we're really pressing down so we've got some good connections. There's nothing there. Again, we've got absolutely nothing on that one. No, we've got absolutely, well, no, let's just try setting that down the range, see if we've got anything there. We've got nearly minus a volt, I think. So I could presume that might be the, yeah, minus, yeah. No, that's not working. That is not happy at all. With nothing there that we should have. Right, so let's get back down on the power supply in question. Zoom you in a little bit. There we go. Right, let's get inside this thing and see what we can find. Get some screws out. And you are going completely along with me with this. I've not had this power supply open before or anything, so what we find now is what we find. Let's see what we've got. Get in here. More screws. Very compact power supply, I must say. And obviously it doesn't have a fan in it. The computer does have a fan in it, which I think is meant to cool this thing as well. Let's see how we can get in it. Still not in it yet. I wonder if there's any hidden screws anywhere. You just have to pull it apart, I don't know. Now, you wouldn't think them screws are anything to do with opening it. They look like they hold the PCB in, but let's take them out. There we go. It was them. So that's the cover off. Let's take this safety shielding off. Right, and here we are. We're inside the power supply. Now we have to be a bit careful here because obviously I've just had this thing powered up. So, oh, excuse me. So there is potential that, because it's a switch mode power supply. This is the low voltage side here, and you can see you've got a nice chunk of separation there, and this is the high voltage side here. Straight away I can see we've got a dirty great big cap there. That's a really large, there's a large capacitor there. So what we will do, we'll take a suitable meaty resistor. Let's just it's not a very high value, this one, so there may be a bit of a flash and a bang if when I short out this. In fact, let me just find a resistor of a slightly higher value than that one. Bear with me a second. What have we got on here? Let's have a look now. That'll do. That's even better. I've got big 100k 2-watt resistor here. Just bend that like that. And we'll do it safely. And I must admit, if I wasn't filming this, I'd take that resistor in my fingers like that and I'd go like that. But I'm filming this and you're better doing as I show rather than as I actually do. We just short. There might be a small flash and a pop here when I do this, but we just... Nope, there we go. We just short across that capacitor there, just hold it on like that. And all that's done, if there was any charge left in that capacitor, which would be 200, 250 volts, we've just bled it out through that resistor there, just to make it safe. It wouldn't people will probably kill me for saying this, but if you touched it, it wouldn't kill you. It would hurt like buggering. You'd probably throw the power supply across the room with the reaction from it, from the shock from it, but it's not going to kill you. Like I said, it does bloody hurt though. Right, so I'm relatively confident we're safe on this now. Let's whittle the board out. Oh, that is a big capacitor. I've just seen it from the other side. I'm glad I discharged that. Right, now let's winkle this out. There we go. Now, and here we are. Right, we're in the power supply. That's the main smoother. That's what we've just that there is what we've just discharged, so that's safe. And these around here are the capacitors which cause problems in these computers. These are the on the low voltage side. Now none of these actually, if you look at them, look physically like they're bulging, but that's not always an indication. These things can leak and become electrically leaky and not actually bulge the tops on them. Now let's have a look at what values we've got here. This is a bit fiddly to work on because of the way it's all connected together like this, but it's not the end of the world. Now we know that the mains fuse there is okay. We will just double check that with the tester. Let's set that up to ohms. But we know that's alright anyway, because as I said before, there's a slight tick coming from the power supply, and indeed, yeah, that's absolutely fine. Looking closely at the board, we can't see any burn marks anywhere around here. The transformer looks a little discoloured on the top there, but I think that's actually just varnish. There's a bit of discoloration in the low voltage side here, which is where where all the other voltages are really generated, but it doesn't look horrendous. So I think our first port of call is going to be, as they've said on a few of the forum, there's a few of these capacitors which don't cause any problems at all, and there's a certain brand that was used in these which fail with definite regularity. Now, I don't expect these ones here, I don't know if you can see that on the camera, but I don't expect these taller ones here, which are 1000 UF, 10 volt, to be of any problem, because they're Nichicon. They're very, very reliable capacitors. However, these brown ones here, I think they are. Let's see what we've got here. 47 UF 20 volt, that's a Nichicon. It's these ones here, which are a different brand, and apparently they're what cause most of the problems in these power supplies. So what I'm going to do, actually, I'm going to whip out these ones which I've been told are what cause a lot of the problems, and we'll see if we've got something we can replace them with. So, not the easiest power supply to work on. Well, let's get the first of these capacitors out and then we can have a look at it. Clean off the iron. Let's get this capacitor out. Just heat up. That's not good. Need a little bit of extra solder on there. Sometimes with these older boards, you need to reflow a bit of new solder on the legs before you can actually desolder them. It just helps. I think it's a bit of a case of the flux in the solder more than anything. It just helps the old solder to flow. So let's reheat that up now and get it nice and hot. Get in there. That's better. Same with this one. Get it nice and hot. Let's have a look, see if we can get that capacitor out. Yeah, let's come out straight away. Let's make sure we know which way it goes around. So negative is to that side, let's pop that capacitor out. Oh, let's look what it is. This is a Elna. I believe this is the brand that I was warned about, and it's a 270 UF 25 volt. And if we look at the bottom of it, and you probably won't be able to pick this up on the camera, but if you look, it's fairly swelled there, and there's definite signs of leakage around the bottom of it. So that capacitor's definitely been leaking, physically leaking. In fact, you can see quite well that it's really swelled along the bottom there, like I said, and there's signs here of electrolyte leaking out of it. But if you look at the top, it's absolutely perfect, and you do get this with capacitors. So that's one out. Let's have a look here. I believe this is another one that causes issues. That's the same brand, and there's one down here which is again the same brand, different value. So let's get them out at the same time. Now fortunately negative at all points in that direction, so we know that that's easy. Let's get to the next one, which is these two connections there. Now we already know that this solder's been a bit of a pain, so let's get some fresh solder on there before we even start. Let's get a bit on there, a bit on there, like that. Get the solder sucker, we heat it up, get it nice and hot, on with the iron, there we go. Same with this one, heat it up, nice and hot, give it a suck. I'll give that first one another go because it still looked like it was holding on a little bit of that. There we go. Oh, obviously we haven't got smell-o-vision, but yeah, slightly off fish. I have the distinct aroma of slightly off fish, and slightly off fish is telltale of hot electrolyte. It's if you've worked on oh, you daft sod, and this happens all the time. I've just desoldered the wrong capacitor. It's this one we're meant to be working on. I've actually just desoldered that one. That's a rookie mistake. I flipped the board over and obviously got the orientation wrong. So what we will do quickly is we will resolder that Nichicon, which I don't think is ever going to be faulty, back in. Take a bit of this solder, pick it up, straighten it out, and we will double check that we are on the right capacitor, which is this one. Take this one out. One, two, three. One, two. Yeah, that's going to need a little bit more of that one, I think. Let's give that one another last suck. It's not actually critical to use a solder sucker when you're taking components out that only have two legs like that. To be fair, you can most of the times just heat the leg up, pull it to one side, heat the other leg up, and do it that way. We've got one leg free here, the other leg's being stubborn. Alright, let's heat that up again, see if we can get, there we go, it's popped through now. That's scraped off. So yeah, that is another, look at the bottom of that one. That's another of these, long life apparently. Yeah, not as long a life as them Nichicons. It's another Elna long life 270 UF capacitor, and it's also been leaking like a bugger. So we've got one more of them to take out, which let's find out where it is. It's there on the board, so we'll come along. There's a big power resistor there, and it is, that's weird, it can't be that one. Let me just try and figure out exactly where this component is. I've got a big lead there, I've got, aha, it's that pin and that pin. So let's get this one out. So we put a bit of solder on that one, a little bit of solder on that one. Let's heat this. This one. Okay. Oh, that smell. Dear me, that's bad. So it's one of them smells that if you've worked in electronics, you can instantly recognise a leaking capacitor as soon as you heat the leads up. And the smell is, ugh, it's horrible. It's... Have we done it again? We have, you know. We've took the wrong bloody component out again. We'll solder them two back in. It proves, actually, because the component we want's this one here, it just shows how much electrolyte really has leaked there, because I was off that component and the board, the smell, ugh. Let's heat that up. It is very, very unpleasant, really. The only thing I know that's worse than that is a selenium rectifier, the old solid state selenium rectifiers. When them things go off, that is again is one of them smells that if you've smelt it, you'll smell it for the rest of your life. It's one of them smells that lingers. It smells like a sewage farm. These, like I said, it's horrible, the smell. It smells like old fish. That's the only way you can describe it. Again, if you look at the bottom of this, there you can see where all the electrolyte's been leaking on it, and in fact it's all domed up there. But you look at the other side, it's absolutely perfect. But this one is again, it's a Elner. Value on this is 270 UF at 10 volts. So the 270 UF capacitors. Now that really is, let's see if we've got any more of them. I won't bother changing the Nichicons because they are very, very reliable capacitors. I'll try changing them first. That's a Nichicon, that's a Nichicon, that's a Nichicon. What's that one? That's a Nichicon. And that one is... that one I can't see a brand on. I'm thinking I'm going to take that out just so I can have a look at it. And again, it's next to a resistor there, which we can probably identify quite easily. It's... yeah. This one is... those two legs, one there and one there. I think we're running out of solder as well, so let's get some more solder. My solder box. Right, and let's get this next capacitor out. Now, we said it was that one there and that one there. Let's get them on there. Let's heat them up. That's one out. That's the other one. Ugh, yeah. Like I said, that has probably contaminated the whole board, but taking that one out stinks as well. Let's get hold of it with them. Give it a little twist and a pull. And that hasn't got... ugh, that hasn't got anything on it at all, I don't think. Oh, hang on. No. That's actually... there's no markings on that at all. So we need to find out what that one is. C58. So we can find that one is. First things first, let's see what we can do about replacing them, and then we'll look at what we can find out what that is. Let me get some capacitors. Oh, that smell. It's smelling my whole workshop out. And that's all I'm taking for the capacitors out. Right. We have some random new electrolytic capacitors here. Now what this is, I go on eBay quite regular, and I pick up massive lots of mixed components. I only use these for my own stuff. If I'm repairing a computer for someone, or I'm doing a computer up for sale on eBay or on the internet, I don't use these capacitors. I actually go out and buy brand new Vichy or Nichicon or top brand quality electrolytic capacitors. What these are is stuff for my own personal use. So like this computer is not a computer I'm going to be doing up to sell or anything like that. It's a computer I'm just interested to get working. These are all brand new, but I literally buy them as big bulk mix lots, and you've got to go through them and get the good components out and sort out all the dross. But yeah, it's a cheap way of getting plenty of components in decent values. So let's see what we've got in here that we can possibly replace what's faulty there. Now, 270 UF is a bit of an odd value. It's not totally uncommon, but I doubt I've got any. I don't think it's going to be 100% critical, to be honest. So we'll see what we've got that will do the job for the time being. Like I said, I wouldn't do this if it was a repair for someone or anything, but for a crappy old computer which I paid a tenner for, that I'm just interested to see if it gets working, these will be fine. Let's see what else we've got. I think our options are going to be either 220 UF or 330 UF as the standard values. A couple of 220s there. What's that one? That's 1,000. That's 100. That's probably too high. That's another 220. Got plenty of 220 UF. In fact, I think I might use them to replace them. 270s. They're close. If you give them the tolerance, say 20% tolerance, then they're close enough. They're close enough then. It's that's going to be a bugger. We can try it on my capacitance meter and see if it gives anything that's remotely sensible. Let's dig the old capacitance meter out. Come out. So let's dig this out. Let's see what this tells me this capacitor is. It might lie. It might tell me it's a resistor. Alright, that's connected up. Test is running. It seems to be analysing it as a capacitor, so I've usually come up with failure before now. Right. 77.46 UF. That doesn't to say that there's it actually works. Oh, that's the wrong capacitor. What have I just done with that one now? There it is. Right, so let's see what we can stick in its place. Perhaps a 50 UF. Have we got a 50 UF? That's 4.7. What's that there? Ah, there we go. We've got a 47 UF there. So let's give that a try in that that position. Look, it's not ideal. They're slightly below. I wonder if I should use 100 there. That's 220. Like I said, I'm just seeing what I've got. Literally, what have we got there? Ah, right. That'll do. We'll replace it with that. We're going slightly higher in value with that one because that's 100 UF, and then we're going slightly lower in value. But we're close enough, I think, for this. And like I say, it's just an idea, just see if we can get the damn thing to run. We can always look at getting the correct capacitors in the future. These are close enough for testing. Right, so this one is negative that way around. So let's stick that in there. That's the 100 UF to replace that that tiny little one. Stick that in. So I'm just going to push these in place. Hopefully they will fit. They are slightly bigger, a slightly different type of capacitor than what was in there originally, but if they'll go in, they'll go in. Just, that literally just squeezes in there. That one again, let's put that in there. That's negative the right way, that's in. And that one, and we can squeeze that in as well. Yeah, it only just fits that, but that's in as well. So that's the new capacitors in the board. So all we've got to do is solder these in place. We can reassemble the power supply and see if we get anything out of it. So let's just solder these in place. Oh. Okay, that's the component soldered in. And where are my nice snips gone? I've put my capacitance meter on top of them, that's what. Put that away. Grab my nice, they're not exactly expensive Dura tool, but they're nice and sharp. Oops. We'll hold on to them because they're flying everywhere. Snip that. Snip that. Snip that. Snip that one off. Right, okay. So, I think we've got, that seems to be okay. We've got the new capacitors tacked in there. So they're not exactly the right values, but they should be close enough to see if this thing is going to work. Let's put this thing back together. Right. I should probably say it goes without saying really that don't do this unless you know what you're doing. I mean, watch my videos when I'm doing stuff like this by all means, but unless you're actually confident about playing with main stuff, working in the computer itself's no problem at all. You can't hurt yourself. Working on these, if you don't know what you're doing, yeah, you can kill yourself. That's not to say don't do it. I would never say it to anyone, don't do it. I'd just say be careful. Watch some tutorials, watch some videos. Do it safely, do it properly. You don't necessarily have to follow everything that I show as well. I mean, I sometimes take cut corners and things like that. So don't take everything that I show, how I do things, as a given, as that's the exact right way of doing it. But at least it gives you a guide. It's the way that I do it, and I've been messing with old computers and old electronics since I was probably too young to. Before I was 10-year-old anyway. I was messing with mains voltages and things like that. So I'm still here. I'm in my mid-30s now. I won't tell you exactly how old I am, but I'm in my mid-30s. And I'm still here. I'm not dead yet. It's all down to common sense, really. Just so don't mess with anything that's live unless you know what you're doing. When you do know what you're doing, there's certain things you should do, like the old one hand behind the back. Because if you get a shock on one hand, you're less likely to actually kill yourself as if you get hold of something with two hands and you get a shock across your heart. So let's get that in there. So all the screws back in. One more. So let's screw that in there. Okay. Now the question is, do we test it or do we throw... Okay, apologies for that. Yeah, my battery just went flat, but here we are, we're back to it now. You're right, there we go. There's the power supply back together. We've got all the screws back in it. And you know what, I think I'm just going to throw caution to the wind. Wherever it's gone, we'll get the Mac again. There we go. Put the power supply back. Now what we should really do, I mean, if this was a customer's computer or anything, I wouldn't be doing it like this. Like I said, this is I paid 10 quid for this. I'm not really that bothered. I might do some more work on this in the future. Let's just see if it'll actually work, and we'll take it from there. We'll put the power supply back in. Like I said, all we've done up to now, is, if I can find it, there we are, is change them 4 capacitors. That's all we've done to this. Snap that back in place. We'll connect it up to the motherboard, like that. And let's make sure the power supply is in the off position, which it is. And somewhere, there it is. We've got the IEC connector. Let's plug it in. And what do you think? Is it going to run? Shall we find out? Well, the fan. Oh, look at that! Well, we heard a ping. The hard drive's fired up. Yeah, well, looks like we seem to have got the power supply running again. So, obviously, I don't know if the computer's actually working yet. I know for a fact that these hard drives are notorious for faults. They have an issue, these quantum drives, where the heads stick inside them. 2 little rubber bumpers inside them tend to turn to goo over age, and they stick the head so the head can't see across the disk. So it could still be dead. It might need some work to get it up and running. We'll see. But the computer's obviously not dead. You heard the power on ping come from it. The hard drive is spinning, the fan's running. Right, well, I think I'm going to leave it at that for today. I will be doing a part 2 video on this when I can get up into my attic and set it up with the monitor, keyboard and mouse and everything, and we'll see what the computer actually does. Like I said, I don't know about the hard drive yet, because I do know that these quantum drives from this age do have issues now. But yeah, I'm going to leave it at that for now, so thanks for watching, and goodbye.